Hello, welcome back. So as I promised, today what I'm going to do is start talking about pulse width modulation, or PWM, for the use of controlling the speed of our DC motors. I have the robot set up pretty much the exact same way I did before. I've added an ultrasonic up here in the front, which we're not going to use right now. I have this LED, which we are going to use as a reference so we can see the pulse width actually happening. I still have it hooked up to pins 3, 4, 5, and 6 of the Teensy, and those are going to the dual H bridge, the motor driver board, and these two right here, the first two wires, which are connected to 3 and 4, run this motor down here. 5 and 6 go to these two over here, which controls this motor over here. You'll recall that if I set, for example, this one high and this one low, it'll then induce the motor to turn full speed in one direction. If I reverse it to low and high, it puts the motor in full speed in the other direction. I determined its direction experimentally. It turns out the way I've wired it, that is how it works out. You'll have to determine that on your own robot, but know that you have to have one high and one low to go one direction, and one low and one high to go the other direction. Two highs make it stop, two lows make it stop. Okay. I think everything else is going to be the same. So let me explain a little bit more about what is PWM. If we look at it, what it really means, pulse width, we're talking about the width of the voltage pulse. All right. If I have a pulse width of 0, it means essentially I'm not putting out any current. Okay, there's no voltage, nothing going out. All right. If I'm at 50%, it means that for half a duration of a cycle, I am supplying the pin with a voltage, I'm making it high, and half the cycle I am making it low. There's no voltage there. By the way, the Teensy is a 3.3 volt device here, so the 5 volts isn't quite the same. 75%, 75% of the time it's on, 25% of it's off. 100%, 100% on, 100% off. Okay, let's take a look at the Teensy itself. I chose pins 3, 4, 5, and 6 because these are PWM pins. You need to know which pins on your device are capable of doing pulse width modulation. Turns out 3, 4, 5, and 6 are on the Teensy, 9 and 10 are, and this is important where I hooked up my LED, and I'll explain that in a second. 20, 21, 22, and 23. These are also pulse width modulation capable pins. So let's jump now actually to our robot here. And let's take a look at the code. Okay. No surprises here. These are those 4 pins. I've set them up, these 4 pins, 3, 4, 5, and 6. Okay, I've defined them. I also added this LED, okay, which are also on PWM pins. They're on 20 to 22 for the red, green, and blue. The setup, you can see everything is set to output. Okay, everything we're going to do today is output. I don't have to deal with anything coming back. Let's look at the code. You recall, this is probably similar. Because I'm running this on, I don't have any batteries, I don't have any high current supplies here at all, or high voltage of anything. I'm running it off of the 100 milliamp or 200 milliamp USB cable, which is barely enough to work, but it's good enough for bench testing. And to get my robot to go at all, I have to give it a little kick. So I set one pin high and one pin low for 10 milliseconds, and that kicks one wheel into gets it broken free of its inertia, and it gets it moving within a 10 millisecond. I do that then to the other wheel as well. So both of these get kicked moving within 10 milliseconds. Not a lot of time, just enough to get them started. Then I have the real business end here. And what I want to do is I want to come back to this. Let's look at the actual function that I've created here. I now have 2 arguments. I have delay, and I have this pulse width value. This pulse width value, I could actually make this, I don't need to make, well, yeah, an integer is good, is actually a number between 0 and 2, it's an 8-bit number, 0 and 254, okay? Those are what's going to work in this number here. So let's go down to the actual loop. I've written a simple loop just to demonstrate this. I have two for loops, okay? One of them incrementing higher, one of them incrementing or decrementing lower. I started out at 60, okay? Well, that's because, remember, this is a 8-bit number, so 60 to roughly 254 is roughly a quarter of it, right? 60 goes in, 60 times 4 is to 240. So we're at, roughly a quarter, which means, going back to this, okay, 25% is about the slowest I can go and still have these motors move. With this USB supply. If I was on batteries and I had a heftier load back there, I could probably do better. Okay. So what it's going to do is it's going to take and it's going to increment from 60 to 254 in increments of 5. Okay, it's going to add 5 and then 5 and then 5. It's going to call the forward for 200 milliseconds. Okay, it's going to run it for 200 milliseconds, and it then is going to insert the value here between 60 and 254 of the number that's generated within that loop. Once that loop is complete, it essentially does the exact same thing in reverse. It's going to start at 254 and it's going to count down by 5 until it gets to around about 60. Okay, and once again it's going to call it for 200 milliseconds and insert that value into the pulse width. Let's go look at the code again. Okay, 2 kicks to get the motors moving. Alright, in this particular case, I want to move my robot forward, which means that in my particular robot, the first pin is going to go low. Okay, the second pin is going to get pulsed. And by the way, I'm going to shoot another video. This is not the only way to do it. Remember, there's these enable pins. Okay, there's probably the preferred way is to PWM these guys, but we'll do that in the next video. So now I'm going to take and pulse this pin on and off at the value that is generated by this for loop between 60 and 254. Alright, so it's going to be pulsed. The other wheel, okay, the right wheel, one of those pins is going to be held low and the other one is going to be pulsed at an incremental value until the for loop maxes out and it's going to start to go back down. If you look here, what I've done is I kind of want to see it, and maybe you've noticed my light sort of fading in and out because the program is currently running. And I subtracted the 60 because I want my light to eventually go out. And what we're seeing, although it doesn't show up so well on the camera, there you saw it just go out, is we're dimming this light. Alright, so if I load this up, actually it's already loaded, so it should go pretty quick. We're going to get this guy going. Okay, I'm going to turn on my motors, and lo and behold, if you listen and see, it's getting slower and slower. Gets down to a point where it can't really go any slower. Speeds back up and it correlates to this light. So that's PWM in a nutshell. This is 4-wire PWM, so I still have my enable pins held high all the time. One of the problems with this particular technique is, if you recall, every time 2 pins match up, so if they're both low or both high, it puts the motor into an active brake. And there's actually no way to enable a coast feature by holding these pins high. So my next little video, I'm actually going to use the enable pins as our PWM speed control, and we'll just move these 4 pins to a new location. So I will see you again here shortly for one more PWM video. Alright.